A lot of different thinking approaches, including cities, are involved in this work, which makes it, in a way, practical. So, indeed, we have a well-known problem. And in these cases, a lot of times, if you want to solve the problem, what do? What scares you, you close your eyes. So the problem just disappears. So it makes it so much easier if you just ignore it, right? But the problem with this serious problems, they're not going to go away. So we have to actually be able to handle and address them. And, well, looking at the built environment, we have this problem that we have been dealing with over the decades. It's not new. Every time we come up and we say these percentages, and if you have done your homework, you have attended some events, you're interested in this area, you remember these magic numbers. Well, they change from year to year, and it is now that we're dropping below that 40%. Well, when we talk about percentages, doesn't really tell you what's actually happening, but in a way it shows the magnitude of the importance, both in terms of energy and also in terms of really what drives climate crisis and all that with emissions and the environment. Well, problems have been associated with buildings, but well, it's not magic, but problems are going to transform and become part of the solution, which is good. Look at where we're aiming, and today's presentation, especially at the beginning, kind of like we're positioning the issue. And look where we're aiming. Almost zero emissions, almost, because it's never going to be that we do not use any form of energy. That's just trying to minimize it. But who's going to be actually driving this effort and contributing? Buildings. So buildings are now going to become part of the solution, which is good. But let's just do magic. Whoa! 2025 is going to become 2050. And you hit your target. You have a decarbonized Europe. You have a growing decarbonized world. Are we done? No, unfortunately not. Because look what's happening. Whatever damage we have done to the environment, this is going to be there for decades. And the impacts are going to be there. So the issues with the various disaster hazards are going to be there. And we are going to be suffering from those. So this is the word. We need to be prepared. So how do we actually get prepared for all this? And how do we actually adapt? This is the challenge. This is what we're talking about. Already at the European level, there are been already progress in discussing about these issues, and there is a new EU strategy. Here's a link so that you can follow up. Already there is a vision for 2050, along with everything else, how we are going to be adapting and how we're going to be dealing with the, look at the keyword, unavoidable impacts that we'll have from climate change. So this is a good resource for you to get you going and started. To deal with all these issues, and no matter where you live, in Greece, in big cities or small cities, you have been experiencing in different severity this event. And I say different severity because indeed these problems are becoming intense, are becoming extreme, and they are becoming more and more frequent, depending on what we're looking for. For example, we're getting more and more fires that actually get close to our cities, close to the urban environment, close to our buildings. At the same time, we're getting floods. Look at what happened in Greece, what happened in Spain. Very intense phenomenon. And at the same time, we're talking about droughts. So we have water, yes, but we have it too much in a very short time. And then our infrastructure suffers, and we cannot deal with this. So altogether, temperature, high winds, precipitation, snowstorms. Who said that climate change will only bring hot temperatures? This is Athens. More and more, every winter, the kids say, well, when it's going to snow? We're in Athens, so that the school is off. So we get this type of swings and extreme events of, what is this? 46 centimeters in Athens. Come on now. What is this? So this is happening. This is suffering. And I'm suffering from my mic. Hello? Kristen? Yeah, there you go. Thank you. That's why he's the chair. That's a solution for everything. So we need to be able for our urban environment to be resilient, so that we need dependence, regardless of what's happening, to be able to provide for us, for the people. So how do we decide where we are, how good we are? And this is, not going to work, right? So, it's suffering. Maybe need some new batteries, but no worries. We have another mic here, so I'll do it from here. So what happens, and how do we assess where we are, and how good, how resilient our cities, our urban environment. When we're looking at the urban environment, what's the smallest element of these buildings? So when you start with having resilient buildings, then you can say you can grow with the other urban environment infrastructure, but at the end, we will have, as a first step, the resilient buildings. This now, and we have been discussing so much about sustainability, green buildings, sustainable buildings, good buildings. Well, all this help the building structure be resilient, meaning that if you have a very low energy consumption, that's good for all the other good reasons, but that means then you can have renewables, for example, supplying this small demand, and then you can have a mechanical system that can easily be hooked up to your building to provide power if power goes away, if you have a blackout because of a natural event. Again, already, and here's a really important ASHRAE standard, if you're interested to the green buildings, not what the minimum code says, not what CANAC says, but if you want to take it to the next level, you have to do something a little bit better. It's the green standard of ASHRAE. Practical things of what you need to go to pass the minimum demand. There already, as you see, it has elements of the resilience of the building. So among all the other things that you do about the high performance, the green standard, you need to also address these issues. And here's an example. What do you do with your ventilation system if there is smoke because of a fire? How do you control it? How do you actually make your building a healthy environment to continue to be operate under this condition? So here's how we did it in this project. We didn't start from scratch. We had the methodology already available. We had the know-how from where for assessing sustainability for buildings and assessing sustainability of our cities. So the methodology, the structure of how do you use the different indicators, how do you bring them together to have a system was existing. And as I said before, a lot of these elements from sustainability, different indicators, actually apply and are useful within the context of resilience. So we took that along with what's available already in the literature with different existing systems, with the published information. So we collected that because we wanted to make sure that everything is on the table. So altogether, you see, about 180 indicators actually are out there in one way or another, reflecting and describing the issue of resilience. What's more important there? Heat waves, floods, and droughts. Also, looking at the available information, we looked at what the EU, in collaboration with cities, is doing already to monitor these issues. This is an ongoing live process. So what are the most important hazards? This is what the cities, the European cities, are reporting back to the European Commission. So changing temperature, heat waves, precipitation, and drought are the hot issues that the cities are facing. So we need to be prepared for those. And it's only going to get worse. So already that message, I think it's clear, which is good. You have to realize the problem and challenges. So most cities, most EU member states expect that temperature will increase, water will become another priority, and then you have these related hazards. So how do we actually put that now? We took all this information, all these indicators, we organized them, and we put them into that existing system that I told you, and has the way that you can manipulate, that you can organize, that you can work with these indicators in order to be able to come out with an assessment at the end of your building and of your city. All this information now is being integrated in a tool that's going to be available for both assessing different scales, buildings and neighborhoods, cities. In case, and I see some puzzled faces, I hope it is, how do they do this? How do you take energy? How do you take water? Why do you take, I don't know, forest fires, flood, and combine them? Doesn't he know that there are different units, different parameters? You cannot do that. Well, here's the trick. This is what happens behind the scene, and that's what enables us to combine them all together in the system. We normalize, meaning you take the indicator, you take the physical meaning and value with the units of every parameter that is important. And how do you transform that on a scale so that it doesn't have any units, and then magic, you can combine them. In these systems, you have the different value of the indicators, and you identify the two limiting points. What is that? 0, which means it is, my time is over.
No.
No.
We still have 3 more minutes.
Stop the clock, right? It doesn't count. What do I do next? I've got this. I've got this. All right. Right there. Yeah. Got it? So we define the two extremes. This is the optimal value. What is the value that would actually correspond for the different parameter that you use in the indicator, that there will be no risk associated with that? And the peak, the 1, is when, Houston, you're in trouble. You have reached the critical parameter to that. So anything in between, once you define these limits, it enables you to actually normalize that way to a scale that has a score. And you take that into your system, and you may need to weight it with different importance in order to come up with a different result. Here's an example. For example, if you have the hazard of really high temperatures, very commonly associated with climate change. Well, the exposure, you always need an exposure. You need the inhabitants. If people are there, they're going to suffer. So that makes them important. In that case, you may have the population density, the number of residents per square kilometer. Then you have the vulnerability. For example, what can affect the impacts? Green areas. How many, if you have an urban forest, if you have green areas where land can breathe and so forth, it can manipulate the temperature. So you have, for the different indicators, your values. Then you have different weights, meaning there you can play. Is this more important, or is the other parameter more important? And then at the end, you get your score. And if you repeat this for every indicator, you can assess the situation where you start and then scenarios. How do we know that this is going to work? Well, now we're going to actually have the proof of the concept. We're taking it and we have pilots in different cities of participating cities. In Greece, we have Dimophilis, Municipality of Philis, where we're going to work together with the National Observatory of Athens to support them to implement this. The biggest challenge, I'm going to tell you right now, what the biggest challenge will be is finding the necessary input information. So being able to organize the information available in your city, your municipality for your buildings is the first, maybe sometimes the most important step that you need to take in order to be able to advance. Collect the data, assess the existing location, and move on. What at the end we will have, it's going to be open for all of you. It's going to be available for all of you to use. The same thing that has happened with the material that we have and the system that we have for assessing sustainability. If you're interested, maybe you can start with this, which is the Greek transposed adapted information for assessing sustainability that I talked about. It's available free for you to use, open. You can actually manipulate what's out there. You can use training material, training information, and that's going to be repeated now with resilience. And I think that kind of like completes and presents to you a system that you can actually use and put into work. Very important for cities because cities are being challenged with these priorities, and hopefully what will come at the end will make it easier for the technical departments and for all their efforts in order to meet the challenging objectives and make the life for us citizens, either as occupants of buildings, but also as residents in our cities, more effective and more pleasant. Thank you. Very much.